So I'm just going to take you through the problem of the perimeter and the area of a rectangle. We had the little problem the other day of if I make an area, okay, from a piece of rope 40 meters long, what is the best way of arranging the rope as a rectangle to enclose the greatest amount of area? So we are going to use quadratic equations to solve this particular problem. So let's try and think about what that quadratic equation might look like. So we're going to set up a rectangular space. Here, my best shot at a rectangle. And we want to know what are the dimensions of the sides which will enclose the greatest amount of area. Okay, so let's just pick any value for the length of a side. If we know that that side is x, then because it's a rectangle, this side must be x. Which means of the perimeter that we started with, which was 40, we've now only got that much left, however much x is. And we also know that this area is divided evenly between the top part up here and the bottom part down there because it's a rectangle. So that means that the top part must be 20 minus x and the bottom part must be 20 minus x. So that accounts for all of the perimeter. If you add x plus 20 minus x plus 20 minus x, you get 40. Try it out for yourselves if you're not sure. What we're interested in is this area inside the rectangle. And it is found by multiplying x by 20 minus x. So the area of that rectangle is 20x minus x squared. And from our studies of quadratic equations so far, we now know that if there's a negative sign in front of the quadratic term, that this is going to go to a maximum. You're going to get a shape something like that. And we need to be able to find this point here. And to do that, remember, all we need to do is to apply our little formula that we've learned, minus b over 2a. So minus b in this case is minus 20, and 2a, right, a is minus 1, so that's going to give you minus 2. And that tells you that the center point, the turning point of that quadratic equation, is when x equals 10. So x equals 10. Next part, then, where are the two places where there's no area at all? Well, remember that we put the middle point, this point, the turning point, is always equally distributed between the two zeros. The first 0 there, we'll say, and the second 0 there. And we know that if x equals 0, then this whole expression is 0. Okay, if that is 0 and that is 0, the whole thing is 0. So the first 0 is going to be at 0, and the next one is going to be symmetrically on the other side at 20. So there we go. What we notice is that 10 is 1/4 of 40. Okay, and this is always going to be true. If you take a certain length of whatever rope and you say you want that to be the perimeter that encloses an area, it really doesn't matter what that is. We know that the maximum area is going to be 100 divided by 4 and then squared, which in this case is going to give us 10,000 divided by 16, okay, which we can work out on our calculators. So that's it. The greatest area, the maximum area enclosed by a certain perimeter is equal to 1/4 of that perimeter squared. Okay, so that's how you solve a problem of that type. It's an optimization problem, which is why we are even studying quadratic equations in the first place. They allow us to optimize things. Okay, that's the end of that one.